Hello everyone, so here we are again with physics of class 8 and we'll be continuing with what we have learned last time, that is force and pressure. So before we continue with what we have learned last time, let's quickly revise what we have discussed last time. So starting with force. What is force? Force is a cause which causes an object to change its shape, size or its position. And the SI unit of force is Newton. And then we discussed about moment of force. And what is moment of force? The moment of force is the product of the force and the perpendicular distance from a fixed end or the fixed point. And we give you examples for moment of force, that is door, steering wheel, spanner, and we discussed about it, isn't it? That means moment of force depends upon two factors. One is the magnitude of the force, the other one is the perpendicular distance. If the magnitude of force is a lot, that means if the strength of the force is more, then the moment of force will also be more. And if the perpendicular distance, that is the fixed end, and the distance from the fixed end is more, that means the moment of force will be more and less effort has to be applied. So we will be continuing with what we have learned last time, and now we will be discussing about pressure. Now we finished with the force part, now we will be discussing about pressure. And before we start what is pressure, let's discuss thrust. What is thrust? See, thrust is actually force only, but the difference between a force and a thrust is a force when applied on an object normally. Example, I have a palm here and I point at this palm. Now I am using this finger to apply a force on my palm. So what angle does it make over here? My finger with the palm, it makes an angle of 90 degree. That means the force which makes an angle of 90 degree with the surface is the thrust. So thrust is a force which acts normally on the surface. That means which makes an angle of 90 degree, which acts on a perpendicular direction with the surface. So thrust is a force acting normally on the surface. And the SI unit of thrust will be the same as force, that is Newton, because thrust is also force only. Okay. Now, as I told you, I give an example, a force, I have applied this force on this palm with my finger. So, the force here applied acts on a certain area of the palm. It doesn't act on the entire palm, it just acts on a certain area of the palm because I have applied force only on a particular area. That means the force which acts upon this area is your pressure. So what is pressure? Pressure is defined as the force acting on a particular area. That means thrust per unit area. So when I applied a force over here on this palm, I acted this force, this finger is only putting a pressure on a certain particular area. It's not covering the entire palm, just a particular area. That means a force here is applied only on a certain area. So what am I doing over here? This finger is putting a pressure on the palm. That is, so what is pressure? Pressure is defined as the thrust per unit area. That means how much force you apply on a certain area is your pressure. And the expression for pressure is thrust divided by area. You can also write force divided by area. It will be the same. So thrust by area, pressure is denoted by the letter capital P. Not small p but capital P. And since the formula for pressure is force by area, what is the unit of force? Newton. And what is the unit of area? Meter square. So it is Newton per square meter. You know how do we read it? Newton. The slash is read as per. So Newton per square meter. M to the power 2, how do you read it? Square meter or meter square. So Newton per square meter And instead of Newton per square meter, you can also write it as Pascal, named after the scientist Blaise Pascal. So Pascal, and you know the name of the scientist, when the name of the scientist is taken as unit, you don't write in capital, you write in small, P-A-S-C-A-L, and symbolized with capital P small a. So this is the symbol of Pascal. You don't write P as Pascal, it's symbolized as P-A. And 1 Pascal, the relation between 1 Pascal and Newton per square meter is 1 Pascal is equal to 1 Newton square meter. And the higher unit, that is, this is the SI unit of Pascal, the higher unit of pressure is 1 kilopascal. K stands for kilo. So 1 kilopascal, and the relation between 1 kilopascal and Pascal is 1 kilopascal is equal to 1000 Pascal. Now, the atmospheric pressure, you know what is atmospheric pressure, right? Pressure exerted by the atmosphere on the surface of the earth. So, the atmospheric pressure uses, when we are measuring atmospheric pressure, that we don't use Pascal, we use the unit ATM, that's atmosphere. So 1 atmospheric pressure is equal to 1.013 into 10 to the power 5. It's 10 to the power 5. Sorry, there was some error here. So maybe, so it's 10 to the power 5 Pascal. Okay, it's 10 to the power 5. This is power 5. So you can refer your book if you have any confusion here. The relation between 1 atmospheric pressure and Pascal is 1.013 into 10 to the power 5 Pascal. So if you are converting atmospheric pressure into Pascal, you have to use this relation. So these are the relation between the units and the definition of pressure and the definition of thrust. Now, pressure, what's the formula for pressure? Thrust divided by area, or force divided by area. So it depends upon 2 factors. One is force, the other is area. How is it related to force or thrust? Pressure is directly proportional to thrust, which means when the strength of force increases, pressure also increases. That means if I just gently press it over here, it won't hurt much, isn't it? But when you push it really hard, you will have a red mark on your palm, which means you have applied more force. So more force, more pressure. The second factor that pressure depends upon is area. And how are pressure and area related? They are indirectly proportional. They are indirectly related. That means if the area of contact increases, pressure will decrease. If the area decreases, pressure will increase. That means just the opposite. That's why we say they are inversely proportional to area. Now some of the examples. How are pressure in our day-to-day life included? The first one, if you want to pin a nail, or a board pin, what kind of nail do you prefer? A rusted one, a blunt one, or a sharp one? Obviously the sharp one, right? Because it easily gets through the wall. Now why does it get through the wall easily? Because the pointed nail has very sharp point. So the area of contact, that means the area of contact between the pin and the wall will be very less. That means if the area is less, pressure will be more. Thus you can easily drive the nail inside the wall. Cutting tools. Whenever you are cutting any vegetables, fruits, anything, you prefer a sharper one rather than a blunt one, isn't it? Why? Because the sharper one has very thin edge, and when it's a thin edge, the area of contact will be less. If the area of contact is less, pressure will be more. Thus, you can easily cut the fruits or the vegetables. Pointed heels. Now, this is generally for the girls, isn't it? So, girls who wear very high heels, and it becomes very difficult for them to walk. It's not easy for them to walk, isn't it? there are few people who are very much used to walking in the pointed hills, but still comparatively with a flat sole, it becomes difficult to walk with pointed heels because the area of contact with the pointed heel is lesser. When the area of contact is less, pressure will be more. That's why when you wear a pointed heel and then when you come back home, your foot hurts, isn't it? Now, heavy trucks. You've seen trucks, especially those in the plain areas, isn't it? Trucks which are very huge and they have 6 to 8 tires. Why do they have 6 to 8 tires? Because they are increasing the area of contact. If the area of contact is more, pressure by the truck on the ground will be less. Okay, if the area of contact is less, that means if they are using only 4 tires, then what will happen is the pressure of the truck on the ground will be more and the road will be easily damaged, or the truck might not be able to run smoothly. That's why they use the heavy trucks, they have many tires, 6 to 8 tires. And why do they have 6 to 8 tires? To increase the area of contact so that the pressure would be less. Camels, elephants, you've seen those, they have this flat paws, isn't it? They have thick base. Now, why do they have thick paws? Foot of the camel or the foot of the elephants are huge, broad. Why is it so? Because when the foot is broad, the area of contact will be more. And when the area of contact is more, what will happen? The pressure of the body, of their body on the ground will be less. And it will be easier for them to walk. The foundation of building. For those who have seen buildings being constructed, you've seen those bases. The foundation of the buildings are huge, isn't it? Why is it made huge? So that the pressure of the building might not fall on the ground. And that means the area of contact would be more and the pressure of the building will be less. If the foundation of the building are made small, what will happen? Area of contact will be less, pressure will be more, and thus there are high chances for the building to topple. Now, school bags. And the best example that you can relate to yourself is school bags. When you have carried a lot of books in your bag and you have thin strap. When you have thinner strap bag, what happens is if your bag is heavy, it becomes painful over here on your shoulder, isn't it? When you're carrying your bag. But if you have thicker strap, it becomes less painful. Why? Because with a thicker strap, the area of contact would be more and the pressure on your shoulder will be less. And with a thinner strap, what will happen? The area of contact will be less and the pressure will be more. So these are some examples that I've chosen over here. You might have a lot in the book. Please go through your book once and see all the examples. And if there's any query, please ask questions. Now, I've chosen 3 numericals here. So, we'll be doing 3 different numericals. The first one is a normal force of 100 Newton acts on an area of 0.01 square meter. Find the pressure in Pascal. Now, the solution. As you already know, first we need to write what is given. So, force is given because the unit is Newton. So, how much is the force given? 100 Newton. What is the area given? 0.01 square meter. What's the formula for pressure? Force by area or thrust by area. And force is 100 divided by 0.01, and when you simplify it, you get it as 10,000 Pascal. So this is how we calculate pressure. And there are some questions, there are some numericals in your book, textbook. These are the exact questions that I got it from the book, only the numbers are altered. For example, instead of I think 200 I've taken is 100, so only the numbers are altered, the sums are exactly the same, the questions are exactly the same. So I want you people to do it the same way which is given over here. Okay, only the numbers are changed. So instead of 100, whatever is given there in the text, please write down that number, divided by whatever is given there in the text. The second question here is, find the thrust required to exert a pressure of 40,000 Pascal on an area of 0.04 meter square. What is it asking over here? It's asking you to find the thrust. So what is given? Pressure. How much is the pressure here? 40,000 Pascal. And what is the area? Area is 0.04 square meter. And if you are calculating force using the relation between pressure, force and area, then force is equals to pressure into area. You have the value of pressure, you have the value of area, simply multiply them and you'll get the answer. So this is how you calculate the force. Okay, the third numerical, the third and the final numerical for today is find the area of the body which experiences a pressure of 20,000 Pascal by a thrust of 200 Newton. Now here in the third question, in the first question, the question asks you to find the pressure. So which formula did you apply? P equals to F by A. The second question, in the second question, the question asks you to calculate the force or the thrust using the relation F equals to P into A. The third question that I've chosen is to find the area. And what is given? Pressure and force. How much is the pressure given? 20,000 Pascal. How much is the force given? 200 Newton. And how do we calculate the area? Force divided by pressure. Please remember, do not write P by F. It's supposed to be force by pressure. So area equals to 200, the value of force is 200 divided by 20,000. So when you simplify them, you get 0.01 square meter. So this is your area. As I've told you, the numericals which are given in your textbook is exactly the same which I've chosen over here, except the numbers are altered. So I want you to do that homework. I want you to do the numericals as your homework. And there's one more question which I want you to take it as homework. This is your assignment. A girl weighing 50 Newton wears sandals or pencil heel of area 0.01 square meter. So force, this is 50 Newton is your force, okay? Weight is equal to the force, you know that. So weight, what's the weight? Force. So 50 Newton is your force. And area is given, you have to find the pressure exerted by the girl on the floor. So P equals to F by A. So you will find the pressure exerted by the girl on the floor. P equals to F by A using the values 50 and 0.01 square meter. Again, there is another boy who weighs 60 Newton, wears shoes of an area 0.03 square meter, stands on the same floor. So there is a girl, there is a boy who is standing on the same floor. Girl is wearing heels, the boy is wearing a flat. And the area of contact would be different, and the force applied by them on the ground will also be different. What you have to do, you have to calculate the pressure exerted by the girl on the floor, pressure exerted by the boy on the floor, and compare them. That means who exerts more pressure on the floor, or who exerts less pressure on the floor, and that would be your assignment. Using the relation P equals to F by A, you have to find pressure exerted by the girl separately and the pressure exerted by the boy separately and compare them. Okay, so we've completed this, and we'll be continuing with our chapter in the next class. So till then, please do your assignments, please do your work, and use your time constructively. Thank you.